Pass out. Thank you. As you get this paper, please put your name on it. Wait, who sits over there? Oh yeah, Kaden. Okay. So 3, 3, 3, 3, 3. Marilyn, can you join Tyler's group today? Oh wait, nobody's there, right? Yep. Nobody's there? Okay, can you join their group today? Okay. Thank you. Extras. Thank you, Shine. Please put your name on it. P2. Do me a favor and put your group member's first name on there. Zach, let's go. Are you guys nervous? No. Don't be. Did somebody just burp? Oh, they're gonna cut that out. Oh God. Okay, name, group members. Okay, so let's recap from yesterday. You learned about that word again. What was that word? Density. So who wants to summarize for us what that word was all about? Go ahead, Ian. Try it. The ratio of mass to what? To a substance. There's mass, but it's also involving something other. What's the other thing that's equally important? Volume, right? It's a fraction, a ratio of mass to volume. Okay, so density is the amount of matter or particles that's packed into a given area. You guys remember that? Yeah. Into a given space. Okay, so bowling ball compared to beach ball, which one is more dense? Bowling ball, right? There's more stuff, particles packed into the bowling ball. Even though they have the same volume, there's more stuff inside of there. So if you were to put those two in the ocean, what would happen to the bowling ball? It'll probably sink. It's way more dense than a beach ball. Okay, so in today's lab, it is called water density. Okay, I talked about Italian dressing yesterday. Yes. Yeah, so I mentioned the layers. I showed you my fish tank. Yeah. With my sleeping fish up here, right? Yeah. How they are formed. Well, there are two different layers, and it is all based on what? Density, right? These two liquids have different densities. Okay, one of them is more dense than the other, causing it to sink or go to the bottom. So today, what you're going to do on that side is you are going to be finding out, can water be more dense than water? Yeah, confusing, huh? Can water be less dense than water? Okay, so that's something to think about. All right, so what we're going to do now is we are going to transition over to the other side. Let's see. Group 3. Okay, I want you to be, you're going to go to table 1, table 2, table 3, table 4, table 5, table 6, 7, 8. Okay, take your worksheet, take your pencil, find your table. Like I mentioned earlier, you are doing a water density lab. Okay? Using the materials provided, you will attempt to read. If you couldn't already notice. Did you guys notice that? No. The demo tank is up here. Okay, it is sitting here. It's kind of weird looking. It's tilted at an angle. But this is a demonstration tank. So your goal today is to recreate it, okay? And through that, you're going to learn some things about water, okay? Now, AJ, can you go eye level with this thing and tell us what you see? So go eye level with the water right here. So you got to kind of put your head down a little bit and tell us what you see.
It's like a mixture of red and blue, like lighter layers of each color.
Okay, so tell us what do you see on the bottom? Since there are layers, what's on the bottom? What do you see on the bottom here? Like a blue? Do you guys see blue too? Okay, what's above the blue?
Purple.
That's white. We'll call it clear. Okay, and what's on the top? Red is on top. Okay, so what I have here in my demo tank is a series of layers. Okay, there are 3 layers of water. It's just water. Okay, you have red on top, you have clear in the middle, and you have blue sitting at the very bottom. And your job today is to recreate that setup using the supplies I will give to you. Okay, the first thing you are going to get is this container and this wood block. The wood block is just to hold it up at an angle. Okay, so I'll show you what you're going to do. First thing you're going to do is you're going to fill this up in the water. Do you want them to use that sink today or no? Can? No.
I don't mind.
Okay. So when you fill up this water, this is going to be your starting water every time. When you lean it up on the block, you kind of want to have a shore, some land on the top. Does that make sense?
Yeah.
You want to have some dry area, okay? And that's going to help when you're pouring in your colors. Okay, so this is how you start it every single time. And you're going to get a cup like this that has measurements on it, has 100 milliliter as a top measurement. And as you attempt to recreate this, you are going to be mixing things into this cup. Let's say you're trying to make the red layer. And there is a very specific process on how to do this, okay? Now, if I'm trying to create layers in my tub, would it be better to pour it in quickly or slowly? Slowly, obviously. You don't want to stir it all up. So you have to try and pour this on the shoreline, as we call it, or the dry area. Okay, so you're going to slowly just pour it along. And it's going to keep going and going and going. You don't want to go really fast like that, or it's going to stir it all up. And your goal is to create layers. Okay, so you have to go slow. Do you see a layer forming in that one? No, because I did it wrong on purpose. Okay, your goal is to make layers, not do this. If you make a mistake, it is okay. Okay? You can retry and retry and retry again. All right, let's look at the rules. Number 1, use no more than 1 teaspoon of salt each time you make a layer. Okay, you are going to be given salt. As a group, you're going to get one of these containers of salt. You can use no more than 1 teaspoon. Okay, so if you're trying to make, let's say, the red layer, how much salt is the maximum that you can put in?
1 teaspoon.
1 teaspoon. Okay, so don't put more. It's just a waste. It's going to get stuck in the containers. Just don't. Just use 1. That's all you need. Okay? Number 2, use only 3 drops of food coloring at a time. So no more than that. 3 drops is more than enough to give you a blue colored water or red colored water, so just don't waste it. Okay? Number 3, this is probably one of the more important ones. Only water from the beakers should be added to the tub. Okay? What that means is, let's say you're trying to create the red layer. You don't want to do this. You don't want to go, oh, okay, I'm going to put red food coloring right in here. Okay, because it says only add water from the beaker. So you're going to put your water into here, whatever you want to do, mix it, mix it, mix it, and then you pour it in like how I showed you. Remember that procedure, how to pour it in? Yeah? So whatever you mix and you want to put in that water has to go in the cup first, then you pour it in that way. Don't put anything directly into here. And do you think it's a good idea to stir this thing up? No. Yeah, do not do that. The worst thing you could do. Okay? Last one, your red layer, which is on top. Do you think that's a greater surface area or less surface area? Greater. So you're going to need more volume. Okay, so how many milliliters of red water are you going to have? 100. Okay, so your cup is going to be this big. Some of your letters are going to be scratched out because these are old cups, but it's right about there. Okay, that's 100. And your blue is a smaller surface area on the bottom, so you're going to have less. So how many milliliters of blue?
50.
You're going to have 50, which is about halfway down. Okay, so anytime you're making the blue layer, you're only going to put 50 mils of water. Make sense? Okay. Now, you're going to get food coloring, these containers, you're going to get the teaspoons. The other 2 things I did not mention yet were different types of water. Okay? Jediah, what kind of water is this?
Hot.
It's hot water. This is pretty much steaming, was boiling water. Okay? So it is kind of hot, yeah? So you have to be careful. There's a safety button on it. It's pink. It says unlock. So you push the pink button first, and then you push the dispense button to dispense hot water. Okay? Don't do that. I'm only doing that because I don't want to waste water. But that's how you get your hot water. In contrast to hot water, what might you have? You might have cold water, and it is located over here. I know this cooler says cold, but the cold water is actually in this. It's bigger, so you can use this if you would like ice water. Okay? I know what you're thinking. I can read your mind. Do not drink that water. Okay? The reason is, these cups are not mine, so I do not know where they have been, literally. Okay, I don't know if some teacher put something in here that you don't want to put by your mouth. I don't know. But do not drink water. If you guys want water after school, come back here. I'll be happy to give you guys cold water. Did you hear that? Yeah. Okay, but classroom, lab, science, never eat, drink anything in the classroom. Can do? Can do. Okay. Are there any questions on the procedures or materials, anything like that? You guys all good? Yeah. Okay, let's do number 1 together. Explain why you think, for about a minute, why do you think there are layers in here? So I'm not asking what form the different layers or why are the layers different or what is in each layer. I'm asking why do the layers form? Okay, it's kind of a general question. So why do you think there are layers in this, not this one, in my demo tank? Why are there layers in here? So discuss it and then write out your answer. Number 1. Start writing down your answer. Explain why you think layers, for number 1, why do you think layers have formed here in my demo tank? Why is the water not mixing around? Oh, I heard a key word. The properties of density and why is it separating the layers of water? I wouldn't say loud, but collaborative is a good word. Of course you can when it's time. I'm supposed to cover my demo, but I forgot.
Was it last year?
No, I was going to put it over here and then like unveil it, you know, like here's their demo tank, but I forgot. I didn't want to mess up my demo tank.
Yeah, you did.
No, that was a bigger one. Okay, let's do number 2. And then you guys are off. Hypothesize. So using the correct format. What was it? Hypothesize what you will need to do to recreate this demo tank. So the correct format of a hypothesis is if then because. So if we blah 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 blah.
Then blah.
Well, you know what you have, right?
Oh, we can do any.
You can use whatever supplies I mentioned. You had salt, you had cold, you had hot, you had tap water. You do not. No. You need to investigate and hypothesize on your own. No, you cannot feel the water. You can do anything you want with the supplies I gave you, as long as you follow the rules. You guys can do anything you want as long as you follow the.
For the because, can we put like how we know? Like,
Sure.
okay.
Sure. So you're like a past experience? Yeah. Sure.
Does that have to be in that order?
No. As long as you reach your main goal, which is right here.
Yeah.
Because the surface of the water is what?
Because the temperatures are probably different.
Like
Different meaning. Oh, okay.
Are we right?
I don't know. We'll find out. That's a good theory. I mean, you're thinking about it, so it's good. Okay, if you're done, start looking at the data table for number 3. If you're done, while other groups finish up.
What should I call that?
The demo tank. About another 30 seconds to wrap up your hypothesis. Confident? Oh no, okay. Are you guys confident?
yeah.
How do you guys feel? Confident?
That's pretty good.
Experimenting. I can't tell you guys enough how important this step is, okay? Because like I mentioned before, you probably might fail at least once. Yeah, I'm not saying you will, but there's a good chance that you might, but it's okay. Because as long as you are taking down your data, if you are taking observations and noting down what happened when you did a certain thing, if it's wrong, have you learned from it?
Yes.
What did you learn, Zach? If something is wrong, what did you learn?
That's wrong.
So next time. So next time, would you repeat the same thing? No, you wouldn't. Okay? So it's very important. Even if it goes wrong, you have to make sure that you are recording your data. Because what I'm going to tell you right after you have a failure, dump it out, try again. Ryan, did you guys hear? Ryan, you're going to dump it out and try again. Okay, so don't dwell on it. Don't go, oh, we're never going to get it. Look at your notes, make sure you recorded. Let's say you're trying for the blue. Where does the blue have to go? The bottom. Let's say you mix up your blue, you pour it in, it goes straight to the top. Yeah? So many students are going to have the tendency to just dump it. Okay, let's try something different. Yeah? But you have to go back to your data. Record what happened, what you did to the blue, so that you don't repeat that same mistake again. Okay? Because on Thursday, when you guys come back, we're going to expand on this lab, and it's going to be even more difficult. So you have to make sure you get an understanding of what's happening with these different types of water. You know, what is it doing? What are the density differences going to be? So you have to make sure you are taking good notes. So you explain your observations, you say exactly what you did. Did you put a 1/4 teaspoon of salt? Did you put 1/2 teaspoon of salt? Did you put all hot water? Did you put half hot water, half tap water? That's what you're going to do. Okay, so on your table, it says starting water. So what did I do for my starting water on this one right here? When I had the small one right here, what did I do? I just filled it up with what? I used tap water. Okay, so that's your starting water. So what color would you say that would be? Okay, and the second part is where you are going to fill in your information. So based on your hypothesis, what are you guys going to attempt? What is your approach to solve this problem? Okay, and I'm not going to ask for your opinions. I kind of want you to just go for it and see what happens, because you have time as you add things to the water. Okay, because like I said, Thursday, you're going to need this information. Okay? I think that's all I got for you. If you get it, call me over. I want to see. That's all I got. Any questions on procedure, materials? What do you do? When you do start, I will assign you guys to a specific sink, so please just work in that area so you don't get in the way of everybody else. Okay? Your supplies are over there. Person with the shortest hair, can you go and grab one set of supplies for your table, and you may begin. Yeah, right here. You're working right here. You too. Can your guys' tables, Dana, can you guys use this sink? You guys share this sink. Okay? Can you guys share this sink right here? Just be careful of that. Kobe and Jarrell, can your guys' groups use this sink? Share that sink. Okay? So what did you guys end up doing for that blue one?
We put the salt, we put a teaspoon of salt, and then we put the cold water.
But he just did it at one place though.
So you think it's the way you poured it in, maybe? Okay, possibly, because I did say it makes a big difference how you pour it in, right? So if you guys think that's what's causing it, how much water did you put in? 50? Okay, we'll try again. Dump it out, try again. So what did you guys do first? Tell me. Let me see your notes. You put blue, hot water, and you put red. Was it the same kind of water? Okay, so did it make a difference? No. So what did you guys at least learn from all this?
Don't need hot water.
That what?
Don't need hot water.
But what is hot water doing in the tub?
It's mixing it too much.
Okay, but where is the hot water in the tub right now?
On hot.
So what can you say about hot water?
We should put red hot water and blue cold water.
Maybe. So use your mistakes to learn something. So I hope you guys wrote down what happened as you put hot water, hot water, hot water, it went to the top, went to the top. So make sure you track that, because that's going to help you. You do have to make a top layer, right? So you know now what stays on top. Okay? Use that. You got it, huh? Okay, so the blue. Let me see what you did for blue.
We just
Salt, just cold water? Okay, so it sort of stayed down a little bit, but not like mine, right?
Yeah, no.
So what else could you do to make sure that water stays down?
Well, we made it cold because heat rises.
Okay.
But
But so you tried cold and it didn't sit all the way down, but look at what supplies you have available. Is there any other idea you have? Okay, because something has to be done differently, right?
yeah.
So
So I think we should add salt first before like we add anything. Like any salt
to which water?
to the clear water.
You can. But remember, your blue water needs to sit on the very bottom. So that's kind of what yours is not doing right now, right?
I'm gonna drop this in.
Okay. Just cold water? Okay. How much blue is that?
50.
50? Okay. Does it look like it's a clear separation of blue and... Okay, so something is a little bit off as far as why it's not separating with the clear. But the red is good. You guys got the red down for sure. Okay? But now you gotta figure out how do you get that blue to sit on the bottom. So you already put cold water, right? What else can you use that I gave you to help make it sit down?
That's some wonderful insight.
What's your insight, Jasmine?
Okay, so you know how in the ocean there's
Right.
layers?
Mhm.
Why is it that if we mix this kind of water with salt, it doesn't layer, but if you actually dissolve beach, salty water layers?
There are layers in the deep ocean.
Why? But there's salt water, but here we didn't add salt and it layered.
Okay, so what are you're learning things about temperature then? So you're
I think it depends on
maybe.
I know.
Right. But when you see extreme differences like this, you can tell their separation, right? So what can you conclude about cold water, tap water, and hot water?
Water goes like it's
Okay,
more less dense than
that's right. Wait, cold water is less dense?
More dense, I think.
more dense.
So cold water is going to tend to sink, yeah? You guys ever went swimming in the ocean?
Yes.
And you swim deep down? What does it feel like?
Cold.
Does it relate to this?
Yeah.
Yay! We actually get it.
Back into the Ziploc. Was there a Ziploc for yours? Was there a Ziploc for yours? No. Oh, maybe it just goes in the bin then.
No wait, yeah, it was
That looks better. So what did you guys finally realize?
We didn't
It's supposed to both hot water.
Supposed to what?
It's both hot water.
So the red and the blue are hot water?
Yeah. And then the blue is just with salt in it.
Oh, okay. Okay.